Welcome to the Walton Pi. Today we're going to be talking about the net change theorem. So the net change theorem is really just an application of the second part of the fundamental theorem of calculus. The net change theorem says that the integral of a rate of change is just the net change. So for example, it says in symbolic form, the integral from a to b of f prime of x dx is equal to f of b minus f of a. So if we have a function and we know its antiderivative, we can evaluate it from a to b, and that'll be the net change of the function over that time. So let's go through an example, and don't worry, my next video will go through several more examples of this. So let's say that the velocity of a car in miles per hour is given by velocity in terms of time is equal to 60 minus 10t, where t is the time in hours. What's the total distance traveled in the first 3 hours of the trip? So we are trying to find the net change in distance. So the derivative of distance is just velocity. Velocity is the rate of change of distance. So that means that we can use the net change theorem to figure out the total distance that we travel in the first 3 hours of the trip. So the net change is equal to the integral from 0 to 3, because we start at time t equals 0 and we finish when t is 3, of velocity, 60 minus 10t. So we can find the antiderivative, and one antiderivative is 60t minus 5t squared. As we talked about in the last video, it does not matter which antiderivative we use, we just need a antiderivative. So the antiderivative is 60t minus 5t squared, and we evaluate that from 0 to 3. So at 3 it's 60 times 3 minus 5 times 3 squared, and we subtract from that this function evaluated at 0. So 60 times 0 minus 5 times 0. Great. Both of those go to 0. So this is just going to be 60 times 3, or 180, minus 5 times 9, which is 45. So that's going to be 135. So the total distance traveled was 135 miles. I hope this video is helpful in getting a at least brief overview of what the net change theorem is and what it says. Check out my next video and we will go through several examples of this together. I hope this was helpful. If it was, please like and subscribe so that I can continue to make these videos. And regardless, have a great rest of your day and good luck with the rest of your math.